Hello and welcome to the first lesson on fractions, decimals and percentages. Today we're going to be looking particularly at fractions and very specifically at equivalent fractions. Hopefully this will give us the grounding that we need to move on to be able to convert between fractions, decimals and percentages with ease. But let's take a look at the starting point, which is fractions. As you can see, each one of these fractions, or each one of these circles, makes one whole. This one here is just one circle. But, as you can see, this one here has been split into two halves. But a half and a half still make a whole. This one, a third and a third and a third make a whole. 4/4 make a whole. 5/5 make a whole. 6/6 make a whole. This one is 8/8, 10/10, and this one 12/12. But you can split a whole into as many pieces as long as they're all equal in size, then you split them in proportion. Let's have a look at this one. Hopefully this is just a little starter, just to get our brains going in the idea of fractions. So pause the video at any time, just write down what fraction of these shapes is shaded. Okay, now I'll give you the answers. For part A, well, 3 out of 4 was shaded. For part B, as you can see, you've got 5 shaded out of 8. And for C, we've got 1 out of 2 parts of the shape was shaded. For part D, we've got 2 out of 4 were shaded. E, we've got 3 out of 6. Now we'll talk about simplifying this a little bit later on, but that's finding equivalent fractions. At the moment we're just saying what we see. So for part F we have 5 out of 6. For part G we have 4 out of 9. For part H we have 1 out of 6. For part I we have 2 out of 2, which, as we just pointed out on the last screen, is a whole. And for J we have 3 out of 8. K we have 2 out of 5. And for L we have 2 out of 4. Hopefully that was nice and easy, but that's just an introduction into fractions and finding fractions. Now, if you have a look at this slide, we're going to talk about equivalent fractions. Now, on the previous slide, I talked about 3/6 being equivalent, or being able to be simplified to a half. What I'm about to do here is show you how that's possible by this picture that you can see here. Each of these sticks is the same size, they've just been split up into different segments, and each segment is different sizes. For instance, this stick here has been split up into 1, 2, 3 equally sized parts. If we take this first shaded bit and we compare that to the stick below, which has been cut up into 6 equal parts, then you can see that the shaded part is the same as 2 of these bits. And on the bottom here, this time it's being split up into 12 equal parts, and as you can see, the same amount shaded on the first stick is equal to 4 of these parts. Well, mathematically, I'll just leave that there. Mathematically, that's quite easy to point out, because if we think about it, we have 1/3, 2/6 and 4/12. If you notice, all we're doing is doubling that bottom number each time, and as it happens, we're doing exactly the same to the top. We're doubling the top number each time. And equivalent fractions is all about keeping the proportion of the top the same as the proportion on the bottom. So let's have a look at this one, for example. I've got this fraction 2/5. I'm going to double the top, which will give me 4. But in order to keep it equivalent, you have to double the bottom. And 5 times 2 is 10. So there's a nice simple equivalent fraction. But you don't always have to double. What about if I was to times by 3? Well, 2 times 3 is 6, but I have to do the same to the bottom, so 3 times 5 is 15. Well, that's quite straightforward, so let's see if we can do some more. I'll now times by 4, times by 5, times by 6, times by 7, times by 8, and even times by 9. So, let's see if I can come up with these 6 other equivalent fractions. Feel free to pause the video, write down your solutions or your estimates first. Okay, well, here goes. So 2 times 4 is 8, and 5 times 4 is 20. 2 times 5 is 10, 5 times 5 is 25. 6 times 2 is 12, and 6 times 5 is 30. 2 times 7 is 14, and 7 times 5 is 35. 2 times 8 is 16, and 8 times 5 is 40. 9 times 2 is 18, and 9 times 5 is 45. So there you go. Equivalent fractions made simple using the cloud method. What I'm hoping you'll do now is have a go at this fraction. Come up with at least 6 other fractions that are equivalent to 6/14. When you've done that, bring it into lesson and we'll be ready to start the next part.